Hello students, welcome you all back to my channel Khan's Commerce Tutorial. After completing the subject Business Statistics 1, now I am going to start the second part, Business Statistics 2. Because there is a lot of pressure from the students, from my viewers, to give the topics of Business Statistics 2. So already in Business Statistics 1, we have covered the basics of statistics, introduction to statistics, diagrammatic graphic presentation, measure of central tendency, measure of dispersion, skewness, and correlation analysis. These are the topics we have covered already in Business Statistics 1. Now in this Business Statistics 2, advanced topics of statistics, regression analysis, time series analysis, index numbers, probability theory, and theoretical distribution consisting of binomial, Poisson, and normal distribution. These are the topics we are going to cover up in this topic of Business Statistics 2. First of all, it gives me great pleasure. I thank a lot to my viewers. Every day views are increasing, watch time increasing, and I'm getting a lot of likes, comments on my videos. Thanks a lot. That gives me a lot of encouragement, lot of enthusiasm to give more and more videos, so that it will benefit to all the students of commerce, accounts, and finance. Already I have prepared the videos on financial management, investment management for MBA students, and it is already there in the playlist. And for BCom students, I have uploaded advanced accounting, business statistics 1, corporate accounting. Now I am starting business statistics 2. So thanks a lot. Keep watching, share it, like it, and subscribe my channel. That's my vision, that more and more students should increase their knowledge by watching my videos. I'm explaining in detail the concept, the various concepts, and also we are doing the problem. So now let us begin with the subject Business Statistics 2, theoretical distribution. Now, there are two types of distributions called observed frequency distribution and theoretical frequency distribution. What is frequency distribution? Already we have covered up in Statistics 1. When the data is collected and presented in a table, classifying the items of the data in some groups, that is called frequency distribution. The frequency distribution can be again classified into theoretical, observed frequency, and theoretical. Observed frequency distribution is the actual frequency distribution where we collect the data actually from the given observations. Best example of observed frequency distribution, a class consisting of so many students. We have classified the marks of students in a frequency distribution. So how many students got so and so marks? How many students got so and so marks? So we have classified the marks of students in a distribution form. That is observed frequency distribution, actual frequency distribution, right? The second type of distribution is theoretical distribution or probability distribution, where we make the frequency distribution not from the actual data, but from the data which is deduced mathematically through past experience or by applying some consideration, some theoretical consideration. We make the theoretical frequency distribution. See here, the frequency distribution, the probability frequency distribution is very much needed, because the probability will be used wherever there is uncertainty about happening of the event and future is completely uncertain. The business organization has to make the planning about the future. Future is uncertain, so we use the probability. So probability distribution will give the information about the expected random variables. So that's why this theoretical frequency distribution is very much needed in business organization for their planning purpose. So making the frequency distribution through mathematically, deducing mathematically by the past experience or according to some theoretical consideration will make the frequency distribution, that is called theoretical distribution. Broadly, we classify the theoretical distribution into two categories, that is discrete probability distribution and continuous probability distribution. The discrete probability distribution will be applied when the random variables will take whole numbers. Fixed numbers it will take. It will not take any fractional value. So where the random variable will take the whole numbers, we apply discrete probability distribution. Whereas when the random variable can take any value, whole number or fraction, we use continuous frequency distribution. So under discrete probability distributions, we have two types. That is the binomial distribution and Poisson distribution. These two distributions are discrete probability distribution, whereas the continuous probability distribution is normal distribution. So in the coming videos, we'll discuss more about Poisson and normal. Presently in this video, I'll explain the first discrete probability distribution, that is binomial distribution, and we'll do the problems, right? So first, binomial distribution. Binomial distribution is also known as Bernoulli process because its name is associated with the Swiss mathematician James Bernoulli. So he has explained that how to find out the probability under certain conditions. So this process, Bernoulli process, will be applied in an experiment which produces dichotomous result. An experiment which produces dichotomous result. Dichotomous का मतलब two. The outcome of the experiment should be two. Just like example, when you throw the coin. If you throw the coin, you may get a head or you may get the tail. Any you can get. Forget about the extreme cases. That coin खड़ा हो गया तो क्या होगा? या फिर शोले coin रहा तो क्या होगा? That is a different thing. That is abnormal cases. We are not concerned about abnormal cases. We are concerned about the normal cases. When you throw the coin, you may get head up or you may get tail up. So two outcomes are there, head or tail. Similarly, when you write the examination, the result may be pass or fail. Again, I'm telling normal cases. Don't go for abnormal cases. Suppose if the result is withheld or something different like that, forget it. Normal cases, passing or fail. So these two are the outcome. This is called dichotomous result. So any experiment which produces dichotomous result, there we can apply binomial probability distribution. Now, conditions for using binomial probability distribution. When we can use the binomial probability distribution, the experiment is conducted fixed number of times. When the experiment is conducted fixed number of times, where the outcome of one will not affect the outcome of the other experiment. If the experiment is repeated one after the other, the effect of one will not affect the other experiment. That means the first trial does not affect the result of the second trial. The result of the second trial should not affect the third trial. Every trial will be independent, fixed number. And every experiment should produce only two results, success or failure. Then only we can apply binomial distribution, Bernoulli process. Next, binomial probability function. This James Bernoulli has given one formula to calculate the probability under such certain conditions. अगर वो condition satisfy हो गए, the experiment is conducted n number of times, fixed number of times. Every experiment will produce two results, success or failure. The success is denoted as P, failure is denoted as Q, and number of times is denoted as N. Suppose if these conditions are satisfied, then we can find out what is the probability of R successes in N trials. If the trials are repeated N number of times, what is the probability that R successes we can be able to get in N trials? Formula is P of R. This is read as P of R, probability of R. So P of R is equal to NCR, P to the power of R, Q to the power of N minus R. By using this formula, we can be able to get what is the probability of R successes in binomial distribution, right? This NCR is a concept of combination, permutation and combination. One chapter is there. After completing this unit, we'll start that unit also, permutation and combination. In that, we have to study in detail regarding this combination. Right now, you must know how to calculate NCR. I'll explain it. P to the power of P means probability of success. Q means probability of failure. So this formula we are going to apply in the problems of binomial distribution. Now, characteristics of binomial distribution. What are the characteristic features of this binomial distribution? First of all, random variable should be discrete. The first characteristics feature of this binomial distribution is it will be applied only when the random variable is a discrete variable. It should not take a range of values, it should be discrete values. Secondly, the mean of a random variable is n into p. N stands for number of times the experiment is repeated. P stands for probability of success. So when you multiply n into p, you will get the mean of the distribution, mean of the binomial distribution. And variance. If you want variance, standard deviation square, then npq. Multiply npq. Similarly, standard deviation. If you want the standard deviation, simply put npq under root. Because standard deviation is under root of variance. Under root of variance. So npq under root, you'll get the standard deviation. And expected frequency. Expected frequency you can find out by multiplying capital N with the P of R. Probability of R successes will be multiplied with the total of the frequency. Total of the frequency. We get expected frequency according to binomial distribution. The main parameters of binomial distribution is N and P. N ka matlab number of times the experiment is repeated. P stands for probability of success. So if you have these two parameters, N and P, definitely you can find out the probability of any value. The probability of any value we can find out according to binomial distribution law. Now, importance of binomial distribution law. This probability distribution, binomial probability distribution is widely used mostly in quality control, where we want to find out how many defects, number of defects. What is the probability of 2 defects in a lot of 100? What is the probability of 1 defect in a lot of 10? Like this in quality control, normally this binomial distribution will be widely used. But the condition is only 2 outcomes should be there in the experiment, right? Now, the last thing I want to discuss in this binomial distribution is how to calculate NCR. NCR. Because in every problem, in most of the problems, you must have the ability to calculate NCR. NCR is equal to n factorial divided by r factorial into n minus r factorial, right? This symbol is called factorial. Now, if you have a good practice on how to calculate, then your time will be saved while doing the problem. You will not be confused when we actually do the problems on binomial distribution. So we'll have just a simple practice of doing NCR. Then we'll start the problem. Okay. Now NCR. Let us take n is equal to, let it be 6 and r is equal to 4. Suppose I'll take an example. N is equal to 6, r is equal to 4. So here we can write 6c4 is equal to 6 factorial divided by 4 factorial into 6 minus 4 factorial. This is the expansion of 6c4. What do you mean by 6 factorial? Multiply 6 with all the lower values below 6. So 6 into 5 into 4 into 3 into 2 into 1. This is the meaning of 6 factorial. 6 से नीचे उतरेंगे 6, 5, 4, 3, 2, 1 multiply it. उसी तरह 4 factorial 4 into 3 into 2 into 1. 4 factorial. 6 minus 4. 6 minus 4 is 2. So 2 factorial. 2 factorial का मतलब 2 into 1. That's it. Now cancel the values here. 2 into 1, 2 into 1 will get cancelled. 4, 3, 2, 1. 4, 3 is there. Here 4, 3. Here 4, 3 cancelled. Now 2 1s are 2. 2 3s are 6. 3 5s are 15. That's it. So we got the value. 6c4 is equal to 15. 6c4 is equal to 15. We got the value. That's it. Now I'll give another example. Suppose if we take 10c4. 10c4. So 10 factorial divided by 4 factorial into 10 minus 4 factorial. This is the expansion of 10c4. Now 10 factorial का मतलब 10 into 9 into 8 into 7, 6, 5, 4, 3, 2, 1 पूरा जाना पड़ेगा. It's a lengthy process. So why to go? There's a shortcut method. 10 minus 4 is how much? 10 minus 4, 6. So denominator you are having 6 factorial. Denominator you are having 6 factorial. So numerator also will stop at 6 factorial. Will stop at 6 factorial. That is equal to 10 into 9 into 8 into 7 into 6 factorial. I am not going 6 into 5 into 4 into 3 into 2 into 1. नहीं जा रहा हूँ. क्यों? Because denominator में 6 factorial है, we can easily cancel it. तो 4 factorial, 4 into 3 into 2 into 1. 4 factorial. And 10 minus 4, 6 factorial. So into 6 factorial. Now what will happen? 6 factorial will get cancelled. So this 6 factorial will get cancelled. Now we can cancel 4 ones are 4, 4 twos are 8. 4 twos are 8. This 2 and this 2 will get cancelled. Right? 3 ones are 3, 3 threes are 9. Over. Now 10 into 3, 30. Into 7. 210. That's it. 10C4 is equal to 210. We got the answer. We got the answer. Hope you understood how to calculate NCR. How to calculate NCR. This requirement is there for solving the problems on binomial distribution. You must have a perfection in calculations. So again, one more example, one last example we'll take. Then let it be 20C6. 20C6. N is equal to 20. 6. R is equal to 6. So 20 factorial divided by 6 factorial into 20 minus 6 factorial. This is the expansion. Now 20 minus 6, you will get 14. So we'll stop at 14 factorial. That is equal to 20 into 19 into 18 into 17 into 16 into 15 into 14 factorial. 14 factorial. Now 6 factorial, 6 into 5 into 4 into 3 into 2 into 1. 6 factorial. So 20 minus 6, 14 factorial. So into 14 factorial. Now cancel 14 factorial, 14 factorial. Right? Here you can calculate 6, 5, 3, 2, 1. So easily we can find out here 6 ones are 6, 6 threes are 18. 3 will get cancelled. 4 ones are 4, 4 fives are 20. 5 will get cancelled. Over 2 is there. 2 ones are 2, 2 eights are 16. That's all. Denominator all 1. So we can take the numerator 19 into 17 into 8 into 15. Now if you multiply this 4, you will get 20C6. This is the method of calculating NCR. Hope you got the basic information about theoretical distribution. In this video, this much is enough. What is theoretical distribution? What is binomial distribution? What are the conditions required for applying binomial distribution? What is the formula for binomial distribution? Characteristic features of binomial distribution and importance. These are the things we have studied. Now we'll apply the problems, apply this technique in the problems in the next video, inshallah. So keep watching, share my videos and like it, and please subscribe my channel.